look at, and we already kind of talked about this this problem where it's f of x and then we got negative 2x plus 3, and how we know that that's a reflection over the x-axis. We know that's going to be a vertical stretch factor of 2. That's going to be a vertical translation up 3. We know that. The last sort of thing that we got to be ready for is they might tell us that f of x is equal to 2x and g of x is equal to, let's say, 6x. And they're going to ask for the transformation. Well, it's slightly different now because f of x isn't x, right? It's 2x. But what we need to look at is what happened from here to here. What transformation occurred? Well, we took our original f of x and we times it by 3. Right? We times it by 3 to get there. And anytime we're timesing by 3, that's going to be a vertical stretch. So that would be a vertical stretch by a factor of 3. Okay, so look at your original, look at your new one, see what happened to get from the original to the new one. All right, the only other thing that we got to make sure of, they're going to ask you to graph here. They're going to ask you to graph, right? You see it here, it says graph these two. Both of these are just y equals mx plus b. All right, they're y equals mx plus b. So, for example, for this one, where I've got a y-intercept of 3, so I would plot that y-intercept at 3, and then my slope is negative 2. That's a negative 2 over 1. So from that intercept, I go down 2, I go over 1 to get my next point, and there's my line. Okay, so it's just y equals mx plus b. That was back from a previous lesson, right? 3.4, I think it was, maybe 3.5. I think 3.5 actually. So you're going to graph that. You're going to graph this. That's the same thing as saying f of x is equal to 1x plus 0. So an intercept of 0, a slope of 1 over 1 when we go to graph that. That's it for this section. Hopefully we're good to go on the second half here of 3.6.